Okay, so I've been promising we were going to do a BInatone Route 66, and here we are. So it's one I bought off eBay a bit back, and it's got a broken meter. So, you know, these kind of things aren't going to fetch much anyway, and especially in this kind of condition. I think this is the early version, and if it is the early version, it's an absolute swine to set up. These have a reputation for being a bleed over box, but I'm in a rural area. Unless you're in a big city and there's lots of illegal activity, illegal high power, then it isn't a problem. Get good results, good transmitted audio, though it's a bit clipped. And they usually achieve 4 watts, which is more than can be said for modern radios. So made in Japan. The only other thing that uses this chassis, I'm talking about the later version, because the early version uses a PLL02A synthesizer chip, the later version uses the LC7137, and the later chassis also found its way into the Eurocom EU40, DX40 I think it was, which was done by Zycom Electronics at Ripley in Derbyshire. I went to them a couple of years later in 1983 asking for service information, and they denied ever having made CB radios. No, never mind, their address is on it all. We'll do a Eurocom, I've got a few on the shelf, and the other version, the Eurocom EU40, whatever it was, the other version, which looks a bit like a Eurosonic Euro 1, but it is not. It's a unique chassis. It works quite well, you know, it's got adjustments for adjustments, but it seems to work quite well. It just makes me wonder if the boards came in from the Far East and were finally assembled in the UK. It just isn't like anything else. So, dare I power this up without going inside? So, standard Uniden type connector on the back. I say these are made in Japan. But yeah, I'll tell you what, we will. At the end of the day, it's my radio. So if I blow it up, that's my radio. We have the power leads for these. I just can't be bothered to go and get one out of stock. Oh, helps if you turn the power supply on. Right, well it is on, and it's drawing 43 milliamps. Well, that doesn't do a lot, does it? Right, I have to see where. Of course, I haven't looked. I should have printed out I probably will do the eBay listing for this, but not saying who it is, because I just love eBay listings. You know, I know nothing about CB radios, and I don't know how to test it. And then you look on previous stuff they've sold, and everything they've sold has been a CB radio. Well, I don't say it just doesn't work. We're going to go and get a proper power lead, and we're going to do a printout of that thing. Right, so I've got the... oh, we haven't done a sheet for this radio. That's something else to do. I'll be backwards and forwards like a yo-yo. Looking for the pen just to cross out the vendor on this. What they've sold me is absolutely fine, but I don't believe the story, you see. So BInatone Route 66, 40 channel 4 watt FM mobile CB transceiver, Van CB, right. BInatone Route 66 vintage CB radio, 2781, 40 channel 4 watt output, came from a friend's house clearance, not tested as I don't have the means, spares a repair, might be handed to somebody, no resistance. So it spares a repair, absolutely fine, no problem at all. But when I look on previous things, he's shown sets which are on and into a power meter, and power meter not included. So, you know, there you go. So as long as this has been in somebody's garage, hasn't it? Shed. So this could be, I think this is the early one. So we need to look at the phase lock loop chip. I mean, I know it's the early one because I can see all the extra works, and it's the PLL02A down there. A lot of alignment extra which you wouldn't have on the normal version. I think the worst one of these I bought, this heatsink was missing, the chip was missing. It was like new in a box, but the heatsink and the chip was missing, and it took years and years for me to come up with a scrap chassis which had a heatsink on it. Because I'm not going to scrap something to turn it in. You know, I don't scrap things. It's only when we buy in scrap chassis. So open it up. It could be as simple as the on and off switch being resistive. But I thought this is going to be an interesting set to do, and I like these. But I don't like this version. I like the later version. Ah, right. Well, this is going to be the problem, isn't it? Because it's been in such a wet environment. It's all corroded down here. But we should be able to deal with that with the chemical cleaner. So I'm going to turn the power off and go and find the chemical cleaner, which we'll borrow off Mr. Chippy's. Yesterday we borrowed his Torx driver, so I'll just put those back. Right, here goes. I've never had dry joints on these, never had duct capacitors on these. I've only seen 2 of this version. They've all been the later version with the more usual phase lock loop chip. We've actually got the board rotting away there. Shouldn't matter because it's just part of the ground plane. Just go doing a bit on the channel selector board just in case that's been affected. You just don't know whether it's been underwater, do you, on this edge? So without going under components, that's probably about where we're going to be with it. Don't think there's any damage anywhere else. This is a filter which is done with the spectrum analyzer. Every time I do one of these, oh, you never did that. Well, I don't, because if we're going to use a spectrum analyzer, it's going to cost more, isn't it? if you ever see an increase in output because you do fiddle with those without a spectrum analyzer, well, you've got it wrong. I would expect them to be near the top of the travel because it'd be it's a bought-in part, more likely to be aimed at the CPT market by the manufacturer of the part. Right, well, that's got to dry. Right, we'll try powering it up again. What I have done in the meantime is to clean the on and off switch with the fiberglass brush, because you can see that the potentiometers are both corroded. So we're still getting 41 milliamps coming through the set. Let's get a test meter out. As ever, I can't remember whether these are a floating chassis or not. Yes, I've got the service manual in front of me. So let's just put negative on the negative power lead. Just do the other version of the test, and let's just see whether we've got it on chassis. Go to something we know is going to be connected to negative. Go to the chassis. No, it's a floating chassis. So we need to know why we've got nothing happening beyond an on and off switch. It's a good manual as long as you've got the right version. And I think the manual is mainly going to be talking... Oh no, because it shows both versions. It's showing the PLL02A that's the LC7137 version. This is the right version for us, the PLL02A version. So it's 018538. I think the other version is stroke A. Yeah, 8538A. And it says that on the back. And this didn't, when I saw the photos, I didn't see the A, so I thought, hey, that's going to be the early version with the multi-Watts mixer. Multi-crystal mixer. So, well, how does the meter lamp work? Well, theoretically, you should have the meter lamp working if the meter lamp works, because it comes straight to the on and off switch. It's not even a ballast resistor. So, the fact we've got power to the on and off switch, what have we got next? We should go to pin 1 of the audio IC, because I've not got a speaker plugged in. It might work more than we think. Let's go to PA speaker and switch to PA. Testing 1, 2, of course there's nothing. If we turn it over, pin 1 is going to be what? Is this cobweb or is this? Yes, that's cobweb. Pin 1 is one end of the or the other, isn't it? Let's put that on earth. So we've got 13.8 volts at pin 1. The fact you've got a voltage there, you'd expect to be able to get a buzz. Let's go back to CB. Well, that's certainly dead. Right, we'll come back to this. Okay, we've got it making noises. The CBPA switch wanted cleaning. So we go into PA and switch the loudspeaker around. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. So that's one thing which we can now tick off the list. We've got no RX lights, we've got no meter lamp. No doubt the bulbs have failed. Doesn't help, does it, when that happens in trying to fault find. Right, back to the other socket. We've got picture in picture on? No, but we will have. So on the low power scale we're on channel 20 and we have got 1.8 watts. Channel 1, 1.9 watts. Channel 12, channel 40, 1.8 watts. Transmit, go back to channel 20. Current is 844 milliamps. Low power. (310 milliwatts). Frequency. 27,79085. So let's get the signal generator to that for a fair test. We can also plug the test equipment in now, because we know we're not going to be putting funny voltages up the test gear. So the only intervention, apart from cleaning the printed circuit board and turning the channel selector switch around about 100 times, has been to clean the on-off volume squelch and the two switches on the front panel. You're going to need an earth for this. these days we don't run an earth through the extension speaker socket when we're on the test gear. I may as well just connect that to you know what, power negative if I can find it. Yeah, there. Okay, so we're now going through the test gear. Just check we've got, that doesn't sound like it is earth, it isn't it, but it's come off. Right, let's have a look now at what we've got on the cyanide meter. Very good. 0.51. 0.42. 1. Squelch. So full squelch, go with the attenuator. Full squelch, 310 is 30 microvolts. I'd like it to be a bit more than that, but you never know. We'll do the opposite. Now let's look at minimum. Set threshold on the radio. Straight in at 0.3, that's very sensitive. Meter's not working at all. Right, it's time to go through the procedure. It's quite long-winded if I've got the right version for the manual. So here we go. I've got to make sure we've got the right version. It's because it has this strange American type phase like loop, and it has to be converted. That said, these are really reliable. Now the setup is for whatever version. I think the version is the right one, because we normally struggle with the setup, which is where I've made extensive notes, which are somewhere. So we've got to start with the phase lock loop section, and this is the major thing to do. So in receive mode, we've got to connect the frequency counter to test point 3. So we will. What you can't do is just change one thing and it's going to go on frequency. You've got to change about 3 things to do the frequency. Okay, so where's our lead for the frequency counter? Okay, well the cases are going through the dishwasher. I took the speaker off and it's eaten away. So it's had maggots in it, hasn't it? Probably was working till that happened. No idea where the lead is, so we'll get a brand new one out of stock. So we need to know where the test point is. I've also done a photograph and we'll fill in what goes where as time progresses, and I can scan that and I've got it for future reference. I did this with the other version. Unlike the realistic service manual, it doesn't have a limit spec, which is a shame. Right, we need to find test point 3. That'll be fun. It's going to be 3 hours long by the time we've done this. So test point 3 has got to be somewhere around here. If we're going to adjust T8, T7, and of course the photocopy of which the scan was taken isn't good enough to see. We can see there's a test point something there. I'm going to go to the computer and just manipulate the brightness and contrast controls to see whether I can see that page any clearer not on a copy. Well, after about 40 minutes of looking at circuit diagrams, the test point is capacitor 106, which we'll try and find on the radio. They've actually got proper test points, but they haven't told you. I think it's that one. It's the lower one. It's that one. But that says T13. T813, that's wrong. Eight's that one up there. I can't get an accurate fix. That's so frustrating. First adjustment and I can't get an accurate fix. That's using two different frequency counters and certainly a lot newer than what this was doing. So we can check if this affects the received frequency. We can check that with the other signal generator. Pin 3 of IC4 is our next step. Pin 3 of IC4. Which is the synthesizer. So it is from this way on, it's the third one at the top. 10.2404. How about that, folks? It's VC2 is the adjustment, and VC2 is that one there. So just to prove it, yep, 10.24. So we've done that. So that's going to be receiving, so we have to use a different method for that, which will be the secondary signal generator. Test point 1, we need the correct voltage of 2 volts on channel 1. So pop it to channel 1. I'll turn this off for now, since it's running on battery. Move over to the meter. This will be VCO. So where's my negative? Well, you know, we've got a capacitor, we've got a test point there which isn't labelled. Of course it's not labelled. Chances are that's going to be what we're looking for, if we get the volts we're looking for. So channel 1, that's it, isn't it? 1.8 volts plus or minus 0.3, and you're looking at adjusting T6. So we'll adjust T6 just to prove it. And T6 is the one with the wax in it. Yep, that's it. So that, test point 1. So they want pin 1 of IC5 and adjust T7 for maximum. I might have to use a different meter. Pin 1 of IC5. So how do we get to that? Capacitor 88. So there is this mirror image. IC5, pin 1, and we said 10, I didn't, we said capacitor 88 also goes to it. Well, you know what, I think it's that test point there. It's the lower one. There's capacitor. It's the lower capacitor. So it's actually the second one. So we're looking at maximum adjustment of T7. T7 is that one. And we are at maximum. It's better to use one with either with a needle. I'm talking about an electronic voltmeter with a needle, or using one with a bit of a bar graph, which we do have. In fact, it's behind me. Let's use that. This is much more suitable. This is not where the cheap multimeter is ideal. So once again we'll adjust that, but on this one we've got this bar graph. Right, so that's that. And then in transmit mode, we're going on to test point 3. Which is what we started off and weren't really able to get anything, were we? But this time we're looking for it in transmit mode for 10.695. .695.1. So we adjust VC1 for that. VC1 being that one. .695 precisely. Let's just try and get that 30 something megs. It's just not stable. But that's going to be the receive one, and I said we can use the second signal generator to prove that. So we've done that. So we've done everything except that. Transmitter section. Let's put that to one side. Let's put that to one side. So having gone through all that, it's T10, 11, 12, 13. T10, 11, 12, 13. So what we got? 10, 11, 12, 13. 10, 11, 12, 13. 10, 11, 12, 13. So we're on low power on the radio, so we'll turn it to high power. Let's see whether we can get something a bit more out of this radio. Oh, we need to be on channel 20, don't we? Yes, Mr. Tango, we do. Start again. that's all as it should be. 10, 11, 12, 13, and when we go on to L3, 5 and 6, which is, I think it's these three. Yes, it is. It's all slightly out. Alignment was absolutely spot on that. It's these power things which will want adjusting. Max indication, six and 7 for max indication, and then 6 and 7 one of these, isn't it? It's that one. There we go. It's just a stone's throw from 4 watts. Just check that. Just wanted to check low power, because one of these, that one's the low power, but they're interactive. So that's 400 milliwatts. Back to higher power, it's 3.8 watts. I'm just going to go through these again. Start there. Oh, there she blows. Good grief, that's nearly 6 watts. And then you reduce it on that one. And then we check low power again. There we go. So full 4 watts, which it has no difficulty in achieving. Let's just hope we've got something like that at the band edges. So we've got 4 watts. We've got 400 milliwatts. It's 1.3 amps. Check the other channels. Channel 40 is spot on 4 watts, and channel 1 is 4.05. Right. The next thing is they want you to adjust the meter. Well, meter's broken, so that's something else. We're just going to have to just touch the frequency again, because it hasn't kind of quite worked out. It's well within what's we're allowed to do, but I'd like it just a bit more accurate. it at that. 1, 2, 3. Out of inches, we'll just look at the deviation, which I haven't touched. Wallow. It's reading 1.8 on this test set. Let's see what it sounds like. So usually clipped. Testing 1, 2, testing 1, 2, 3, 4. Yeah, very much so. So on receive, we're going to have to make sure it's on frequency first. So I wasn't able to get an accurate reading, as you saw. Let's put the earth back on the speaker. Take the tone off. And then we'll just connect up our secondary frequency counter. Or make sure we're on frequency, because if you remember, I dropped it, didn't I? Ah, you see. So we've got it best possible on. We've got it best possible. Then you adjust T8. Then we'll go back into transmit and make sure it's a bit high now. Leave it there. We're still on frequency there. So that's receive, that's transmit. That's our receive frequency on the signal generator. I'm satisfied it's on frequency, both transmit and receive. Can you see what fat these are? Hours and hours. This will be edited down to about 1 hour and 10 minutes, I think. The receive on this is working really well. So we better go through the procedure. We've done phase lock loop, we've done transmit, now we've got to do receive. Basically it's 4 and 5, which is your detector. 5, 4 and 5 is the way the detectors work, and then 1, 2 and 3. 1, 2, 3. Straightforward enough. So we'll put a big signal on and show you the oscilloscope. Drop the signal, go over to cyanide meter. Just put a bit more on. Got something loose somewhere. Now we'll go through the front end. Put a bit more on for that and make sure we're in the right way. Yep, that's where we are. So that now gives us 0.55, which is marginally worse than it was before, but of course it's all set up right. 10 dB, 0.46, and for 20 dB is still 1 microvolt. So this gets worse when your detector's right. So sometimes people have fiddled with these and they've just done it with a mate and he sounds closer and better, but the clarity's there, with it obviously being set right. So that's why that happens. And squelch, shall we do that now or shall we come back to it? You've got two squelch controls, you've got minimum, you've got maximum. So squelch maximum is the one we want to do, which is VR1. VR1, where are you? The C1. Make a note of, isn't it? Four, 3, 2. It's that one. It's because it's under the wiring harness. I didn't spot it on the diagram. So maximum squelch. Put 100 microvolts on the signal generator. Show you the attenuator. See whether we can squelch that out. Could be this preset's knackered. Just put some service on that. Yeah, I think we're going to have to replace that. So I'll come back to it in a bit. Right, see whether we can set this squelch up. The thing was, the bit that was the knackered spot was the bit it wanted to be at. I could have set it so it was 30 microvolts, or even coarser, but stupidly coarse. Not quite where I wanted it. Now I've put that part in and it's exactly where I want it to be. It's unbelievable. I'm going to just have to prove it. Yep. It's just where I want it to be. Now the other end you set. So we'll turn the signal generator off, set it to threshold, anyway, I've set it minimum, maximum as far as I can see. Yes, straight in at 0.3. deviation. Let's go to the test set. And then the radio is then set up apart from the meter. The other thing we could have done is take the meter out, take the front off, put the whole chassis in an ultrasonic bath of IPA. That would have been the other cleansing method. Come on, where are you? It's at the back there, isn't it? It's that one right at the back. VR5. You'd think speech processing is going to be here, but I think they use, without looking at the circuit, they're using the preamp in the audio amplifier like an AM set would. Oh, it's 2.1, it's exactly where it wants to be. I'll just pop it up a tiny fraction. Wallow, wallow, wallow. There we go. Oops. Wallow, that's it. And these do clip like realistic handhelds do, of the 1007 variety. So no mention of VR5 anywhere in here. There, we're done. What a pile. Okay, switch it off. Pull the knobs off. I did put the cases in the dishwasher. And you can see the filthiness of... It's been underwater, hasn't it? To some extent. Right, this meter. I think we need to unplug everything. Move the diagrams. Unsolder the meter. Blue to the right. Brown and white to the left. Right, so it's that type of meter. See, if it's had water in it, it's not going to be any good, is it? It's quite a high hour set because the meter's burnt through, the lamp's burnt through the plastic. Just see what I've got on my bench. Let's cut the wires off this one. I want to put some ballast resistors in, dropper resistors in, because lamp straight in isn't ideal. You know, 12 volt lamps on 13.8 volts isn't good. Yeah, and it's got the separate tag board with the lamp. Yeah. So if we change the scale on this, we'll put, this is so much better, it's very low hours by the looks of it. Right, the scale. Be very, very careful doing this. So it's the same way on, because sometimes meters are upside down. It's exactly the same way on. You can see how burnt the one on the right is with the meter lamp, and because of the same meters as near as damn it, we take this scale out, and then we've got to very, very carefully take this scale out. And slip this scale in. Then we'll put some adhesive tape on that, just as they have. Right, so I've done the bulbs. I've put a resistor in here, in some sleeving. We've got 18 ohms for the receive light. We've got 30 ohms for the meter lamp. Considering there was nothing there before, you know, that's going to be a huge improvement, even if they do both still light up like headlights. Back in the business radio days at Nottingham Radio, I remember that Philips radios, they were 14 volt lamps. So these aren't, they're 12, and so they're not going to last very long if you're putting them on 13.8, hence those resistors, which I think was a bit of a mistake at manufacturing level. Oh, it's a 12 volt radio. Oh, it's 12 volt bulb. Well, it isn't, is it? So this has been through the dishwasher, and we've got rid of most of the nastiness. Not all the nastiness. And there we are. Our illegal AM meter with the with the other scale back. Is a check those put in the right place. Is that the right knob? It is. Well, there were two little felt pads. There we are. That looks a bit better. Lot of hours though. Not so much in parts, but a lot of hours. Right, I'll go and get the case. We need to put a speaker on this. Okay, put the bottom lid on. All that now we need to do is to calibrate this. Where's that gone? Oh, look, we've got a loose aerial socket at the back. Glad I caught that now. So we're doing 4 watts, just need to calibrate the meter. And if I get my piece of paper, the left hand one is receive, the right hand one is transmit. There we are, spot on the 4. And on the test set, we're not 100 microvolts, and the left hand one for receive. At the moment it's reading 7. There we're spot on the 9. I mean, the chance of having the right meter is brilliant. And that's why we do have scrap sets, especially illegal ones, which we can use like that. And I like the festoon bulb that's come in that meter. So get those somewhere like tight, and then we can see where I've hidden the last one. So it's been a high hour set which has been very badly stored. It must have done more than, I would say it's done more than 1,000 hours to have got both the meter lamp and the receive lamp to have failed. There we go, that's the other one. Of course these want now slackening off slightly. That looks like it lines up. Nothing worse, you know, when somebody resprays these and they don't take the speaker out. Nothing worse than seeing those screws sprayed over. Right. Does this speaker work? Well, I'm sure they wouldn't have gone to the trouble and expense of being so kind as to send it me if it didn't. Must have had some right maggots crawling out of it for it to have got eaten away the way it was. Right, onto the roof aerial. Turn the test equipment off. So that's back together, and it's always nice that the original sales flashes, despite going through the dishwasher, has survived. One Anna Roger. Well, there we go. Absolutely nobody to be heard this evening. So it's 8 o'clock, we're past our normal time for on the air test, but Mr. Chippy's agreed to stay on so we can get this recorded. So there we are, the BInatone Route 66 Mark 1. You don't see many of those. I think it's only the third one I've seen, and at least I've made a lot more notes this time for posterity. So there we go. So thank you for watching. And so even when water damaged to this kind of extent, I've been able to resurrect it. Thanks for watching.